If you just joined and you didn't get my message, you're going to need your handy dandy calculator, and go ahead and turn in your textbook to page 468. Okay. Um, and so we're going to introduce, or I'm going to today begin to introduce this topic of confidence intervals. And we'll use we're gonna play a little guessing game. But first, I have to do a little introductions to the rules and all of that before we start the guessing game. So first of all, let me just give you a big picture overview of what is a confidence interval. A confidence interval is, let's break it down. We'll take the last word first, interval. It literally is just a max and min value. So we will come up with a value for the minimum, a value for a maximum, with which we have a certain level of confidence that our population parameter that we're looking for, whether it's a proportion, whether it's a mean, a standard deviation, range, IQR, whatever the population parameter is we're looking for, we're going to have a certain level of confidence that that true value of the population parameter is contained between these two values. Do we know exactly where it is between those two values? No, I don't. But I have a certain level of confidence that it will be between those two values. And what do I mean by confidence? Well, think back to when we looked at our Gallup surveys, and we looked at the detail of the survey. The survey results were always expressed in terms of a 95% confidence level, or sometimes maybe it was 99 or 90%, but most often I think it was 95% confidence level. And so that's what we're talking about. In other words, with 95% confidence, we're pretty sure that the value that we're looking for in our population is contained between this min and this max. And honestly, that's what we're going to be doing for the next few days, is figuring out how to calculate these values, and then how to interpret them in the context of a particular case. But before we get into that, I just want to give us an opportunity to kind of experience this this firsthand. Now, quite honestly, this may turn out to be a complete bust. Doing this in the classroom, it works out pretty well. Doing this remotely, I don't know. We'll see. But I'll try to lead you through it. And by the end of the day on Monday, we'll decide, was this a good thing or a bad thing? But in any event, we'll go ahead and get started. So first of all, let's grab your calculator. And I want to reintroduce a couple of functions to you. So first of all, let me start to share my screen. And I want to pull up my calculator. So tell me, can you see the calculator on the screen? Elijah, yeah. Thumbs up if you can see it. Can you see it? Okay. All right, good. Okay. All right. So so there's the calculator. We've looked at one of these functions before, but I'm going to show you another one that we've talked about it. How do you calculate the mean of a list of numbers? And so first of all, I'm going to generate a list. So I'm going to go to Stat and then Edit. And I'm going to put in just not really a random set of numbers, but here we go. set of numbers, which we can easily determine what is the mean of this set of numbers. Okay, so I put in 5 values from 12 to 16. And just by the eyeball method, we can look at this and say, okay, the mean of that list is going to be 14. But my my purpose here is just to show you how this function works. So here's my list, list 1. So now I'm gonna quit out of here. Now I'm gonna go find this mean function. And the way you find it is click the second button and then stat. Above stat, you see list. So we're going to click second and then stat. And then over in the third menu choice is math. And then the third choice there is mean. So you can just push the 3. So now I'm going to calculate the mean of list 1. So I hit second function L1, close the parentheses, hit enter. And I calculated the mean of list 1. And none of us are surprised that the value is 14. And some of you are rightly asking, well, Barry, why didn't you just use the stat, calculate one variable stats, list 1? Why didn't I do that? I could have done that. But in this case, today, what we don't want all of this other data that's in here. All we want is just the mean. So our calculator gives us a way to calculate all of these various statistical functions one by one if we want. If we have a list and we want to just know just the standard deviation, or we want to know just the sum or the max or the min, you can always go to this list and pull these out. Well, the only one we're interested in today is mean. So that's how you get to it. Second function, list, and then the third menu choice over to the right is math, and then mean is the third choice down. So remember that set of keystrokes. And so let me quit out of here, and let me remind you of another function we've looked at already in the probability menu. So click math and probability. And then 6th choice down here is random normal. And let me select that and remind you of what this one does. This one takes a normal distribution that we define its range. I'm sorry, we define its mean and standard deviation. So let's say I want to simulate some test scores, maybe, for example. And so I want to create a normal distribution whose mean is 70 and its standard deviation is 15. And so this might be a group of test scores, and let's say I have 20 students in my class. So what this does is it will randomly generate a list of 20 numbers whose mean, coming from a distribution whose mean is 70, standard deviation is 15. So, and you remember what happens if I hit the enter button now, I get this list of numbers, and they scroll off to the right of the screen, and they're really hard to read. So the best way to deal with these numbers is to store them. Click the store button, and we're going to put it in a list. We're going to put it, I'll just put it back in list 1. We don't need those other numbers. So I'm going to hit enter, and remember the first number was 61.23 something or other. Okay, so now when I go to stat and I edit list 1, here's my list of numbers, 61.23 something or other. So here are my list of 20 randomly generated test scores with a mean of, from a distribution that has a mean of 70 and a standard deviation of 15. And look, you see a lot of values in and around 70. But you also see some values that are pretty far away. 55 there. There's a 56. I think I even saw a 30 something. I see a 30 in this list. Yeah, 37. There's a 96. So there's Gracie's test score, 96. We won't talk about who has the 37, but anyway, most of the numbers are in and around the value of 70s, which is what we would expect. And so now what I want to do is I want to calculate just the mean of that value. And admittedly, I could use my stat calculator to do that. But if I want just the mean value, I can quit out of here and I can go back and select second function list, third menu math, third choice down mean, and now I just plug in list one. So what this is going to do, this is going to calculate the mean of that group of numbers. And I mean, I got to be honest, I'm going to be expecting a number close to 70. And sure enough, I get a number pretty close to 70, 69.4. Okay. So really, all I've done here is just introduce you to the two functions we're going to use today. We're going to use the mean function, and we're going to use the random normal. And we're going to play a game which is described on page 468. So earlier today, I looked around the room I'm sitting in, which happens to be Courtney's old bedroom, which has now kind of been converted into an office or a classroom, so to speak, and it holds a bunch of other stuff. But so I looked around the room today, and I found a 3-digit number somewhere in her room. And I'm going to ask you to guess that 3-digit number using this mean and random normal function. And I'm going to show you how we're going to do that. We're going to essentially calculate a confidence interval for that mystery mean, that mystery 3-digit number. And so let's play a round of this game without the mystery number. I'll give you the number, and then we'll see how it works, okay? So if you look at the activity box on page 468, you can read through there, but essentially I'm going to describe for you what the steps are, okay? So this mystery mean is a number that I have stored in a memory location called M. And if you look above the division sign, you see the green letter M. And so how'd I do that? Well, let's say that the mystery number is 122. And so earlier what I did is I typed in the mystery number. It is not 122. It's just the first number that popped into my head just now. But what I did is I took that mystery number and I stored it by clicking the store button and then the alpha key and the M. So I stored the value, the mystery number, which we're going to say is 122 right now. I just stored it in memory location 122. And you say, well, what does that do? Well, what it does is it's like a locker number. Locker number M, I put the value 150 or 122 in there. And if I go back to that locker number by pushing second function recall, recall alpha M, hit enter, and ta-da, I get 122. Okay. So what I'm going to do is now I'm going to show you how this mystery game works. First of all, what I'm going to do is I'm going to generate a list of random numbers from a distribution that is normally distributed with a mystery mean M and a standard deviation of 20, and I want 16 values in that list. And of those 16 values, I'm going to calculate the mean. So here's how we're going to do that. Second function list, cursor over to math, and then cursor down to mean. So the first thing I want to do is click mean. Now I want to generate a random distribution, a random normal distribution. So I'm going to click math, cursor over to probability, select 6 or just cursor down to 6. So there's my random norm. And normally I would put in a number here. Like earlier, I put in 70 for the test scores. I don't have to do that now. I can plug in this value. This is kind of like algebra. I've introduced algebra to statistics. I'm putting in unknown numbers here. So there's my mystery mean, which we all know is 122 for now, but later on you're gonna try to guess the number. Okay, and so let's see. So now the standard deviation is 20, and I'm going to generate 16 values. And I'm going to close that with 2 parentheses, I think. Now hit enter. And Viola, I get a number really, really close to 122, right? Which I'm not surprised by. The distribution is normally distributed. It's centered at 122, and it has a standard deviation of 20. And I picked 16 values from that list. Let's do it again. All you have to do to repeat that exact process is just use your cursor arrow key, cursor up to that, highlight it, hit enter. That brings that same command back down to the last row on the calculator, and hit enter. I get another mean of 16 values from a distribution that's normally distributed with a mean of 122, standard deviation of 20. So let's do it one more time. And I get another number like 123. Okay. So that's how we play the game. And what I'm going to ask you to do is from the spreadsheet that I sent you the link to, I gave you 4 hints. I gave you my 4 values when I plugged in some unknown number into storage location M. It is a 3-digit number, I will tell you that. So it's between 100 and 999. I've given you 3 hints. Now, the distribution is the same in terms of its standard deviation. The standard deviation is 20, and I pulled 16 values from that distribution. And I've given you 4 hints. So what I'm going to ask you to do between now and Monday is to use this routine, this calculating the mean of a random number, but you're not going to put M here. You're going to put your guess. You're going to put your value, what you think, by looking at my hints. What do you think that value is? And then you're going to generate a mean. And these values here, what you're going to plug in, and just round them to the nearest whole number. So I would plug in 122, 125, and 124 if these were my 4 guesses, okay? So that's what you're going to do. But let me show you a little bit more graphically of what's going on here. So I put together kind of a slide from my smartboard notes. So basically what's going on here is we've got this normally distributed population that has a standard deviation of 20, but an unknown mean. And so what did we just do? Well, out of that population, we just took a sample of n equals 16 values. We pulled 16 values at random from this normal distribution, and we calculated the mean, and we got a value the first time of, what was it, 122, right? 122. So the first time we got a value of 122, and then from here we pulled another sample of n equals 16. And that time, the mean is, and I'm doing this with my mouse, and so this is why my penmanship is so bad, so poor. But the second time we did it, we got a mean of 125. So the second time we did it, the mean value was 125. And then we did it a third time. N equals 16. And the mean of that group of 16 numbers was, we'll call it 124. 124. Okay, so let me ask you this. If I kept doing this, drawing a random sample of 16 values from this distribution, if I kept doing this over and over and over until I had drawn every possible combination of 16 numbers from this distribution, what would I have? Somebody just sing out. What would I have? I'm listening. Anybody want to guess? What would I have? Well, I would have the sampling distribution of X bar for that distribution. If I pulled out all of them, okay? If I pulled out all possible combinations, I'd have the sampling distribution. Well, that's what we talked about in the last chapter, and we learned that that's a huge number, billions and billions and billions of possibilities. And so in statistics in the real world, we can't take all of those possible values, so we take a few of them. And we'll go back to our screen here. So we don't take the 10 billion or the 26 billion or the 50 million trillion possible combinations out of the population. We've done 3, and to get a good idea, we might take 25 more or 30 more of these samples. And if we plotted those values, what would we get? Well, we would get the sampling, we would get an estimate for the sampling distribution of X bar. The mean would be centered on the population mean. Oh, that's terrible. The mean would be centered on the population mean. But we know the standard deviation of that now is going to be the population standard deviation, which we said earlier was 20, divided by the square root of n, which is square root of 16, which is 4. So if we divide that by 4, our new standard deviation, or the standard deviation of our sampling distribution, is 5. So it's much more narrow than our original population. See, the original population's kind of broad, but our sampling distribution is much more narrow, and as a result, it gets taller because more of the values are centered very, very close to the quote-unquote unknown mean, and that's what we got. When we looked at our values, all 3 of these are very, very close. In fact, they're within 1 standard deviation of the true mean, 122, right? What I'm trying to do here is to come up with an estimate of some sort of interval between here and say here that I have a high degree of confidence that the true mean exists between this value and that value. And if I use this thing of 95% confidence, and I think back to these goalposts, then we know from the empirical rule that this is going to lie between plus and minus 2 standard deviations from the mean. Two standard deviations. You remember that from the empirical rule, the 68, 95, 99, 7 rule, that 95% of the data lies within 2 standard deviations of a normally distributed population. And so this idea of confidence now comes from this empirical rule where we have a normal distribution. And we know that 95% of the data is going to come in between these two goalposts. Okay. So I'm beginning to introduce you to the ideas of what is a confidence interval. A confidence interval is made up of a minimum value and a maximum value, and we're going to ascribe some level of confidence that the true population parameter exists between this minimum and this maximum. Now I've got to define that for you a little bit more, and I'll do that on Monday. But for now, we're just trying to figure out what is a realistic max and min value, or min over here and max value over here, for our estimate. Well, if we keep taking a bunch of guesses, here and calculating the mean, ultimately, what we do is we get maybe something that might look like a dot plot. I'm going to have to clear that for just a second. Now, I'll get it back. Okay. So what we get now, something that begins to look like a dot plot. Here is the mean, and I've got to guess at 122, right? My first guess was 122. So in this case, I happen to know that it's right here. My second guess was 125. I'm going to create a dot. I don't know. I will just put it over here for a moment. And then our third guess was 124. So I'll put it here for a moment. Now, in our case right now, we know that the mean is 122. But let's say I didn't give you this value. You could still create this dot plot of values by guessing some number to plug in for M and seeing what kind of dots you get. And I've already given you, I will give you some hints. And so you could say, what happens when I'm going to say, I'm going to take 124. 124 has already happened here. So I'm just going to say, let's guess this mean is 124. What happens? Well, I'm going to go up here. Instead of M now, I'm going to plug in a value of 124. 124. Let's say I just pick 124 as a guess. And look what I get. I get a number like 137. Okay, so now if I go put that on my dot plot, man, that's way over here. Okay, so let's do that again. Let's do that one more time. I'm still going to stay with 124. Now I get a number like 118, which might be over here. Let's do it one more time. And I get 125. We'll call that 125. And so I think that one would be right here. So eventually, if I make enough guesses using this process, I'm going to get a dot plot, and this is what you guys are going to generate. You're going to generate these dots. And I'm terrible at drawing dots. There's probably a better way to do this, but you get the idea, okay? So over time, with enough guesses, I should be getting, and I'm sure you're sitting at home now just laughing your heads off at how poor this looks, but for the moment, just bear with me. And let's say that after a while, we have several dots in our dot plot, and I start near the middle, and I count off the values that fall between these and these. Okay, and so whatever value is here on my number line, and whatever value is here on my number line, this becomes the minimum value for my confidence interval. This becomes the maximum value for my confidence interval. So what we're going to do, you're going to fill in the spreadsheet. I'll show you what it looks like now. Let's go back. Mystery mean, I sent you the link. I'm done. I sent you the link to this mystery spreadsheet, and I plugged in some 3-digit number, M, and I generated the mean of 16 values from a normally distributed from a normal distribution with M as its mean and 20 as its standard deviation. And these are the 4 values I came up with. Okay, so what are you going to do? Well, so Addie's going to come up here, and she's going to go through the process, and she's going to say, okay, what am I going to guess? What value am I going to guess? Well, you see a range here of 232 as the minimum value and 239 as the maximum value. So there's nothing wrong with guessing a couple of times 232 and 239, or she might say, you know what, I think it's going to be in between those and say 235. And so Addie will come along and she'll take her calculator, and she might make a guess of 235. She thinks, whoopsie daisy, she thinks the mystery mean is 235. She's going to plug in 235 here. And let's see what kind of value we get. What kind of value would we expect if the true mystery population value is 235, 228? So Addie will come in here and she'll say, I think the new mean is 228. Okay. Well, Gracie, on the other hand, she thinks, well, I'm much smarter than Addie. I've got a better way of doing this. I'm going to say, I know that the standard deviation is 20. And so I think that the mean could be as far away as 10 from the min and 10 from the max. So Gracie's going to say, I'm going to pick 222. I think the mystery value is 222. So Gracie now will come up here and she'll say, I think I've got such a better idea. I think it's 222. If it is 222 for the standard deviation of 20, and I pulled 16 values out and I took the mean of all 16, what kind of number could I get? Well, I could get a number like 230. So Gracie's going to record 230. Okay? And so each of you will do that 4 times, and you're just going to guess. Now, I'm telling you, these 4 values right here are hints. They're the 4 values that I got when I plugged in the mystery value. And so it's probably not a number like 762. Skylar says, you know what, I'm going to be really creative. I'm going to put in a crazy number like 762 and see what I get. Well, if the standard deviation is 20, then it's going to be really, really, really unlikely that the true number I picked is 762, right? So, but it could be as low as 222. It could be as low as 215. It could be as high as 240, 245. You know, think about a normal distribution with two standard deviations away. How broad, how much data could possibly be in there? So I'm going to let you think about that this afternoon and over the weekend. And so I want you just to come in and you'll put in your 4 guesses here. Okay. I'll take this data before 1 o'clock Monday. I'll take this data, I'll create a dot plot using your guesses, and I'll should be able to send you some representation of that dot plot. And from there, we're going to make brackets around where 95% of the data is. And then we'll say, okay, with 95% confidence, we think the true value is between here and here. And then I'll tell you where the number came from, and you'll be, oh, that's really cute. Okay. Okay. So let me come back to the real world here. Okay. So I'm back.
So just say that someone does get the right number. What do we win?
What do you win? I don't know. What would you like to win?
I don't know.
I can send you any virtual prize that you can imagine.
Oh.
How about this? Somebody might show up unexpectedly and put a yard sign in your yard that says, "Congratulations, senior." How about that? Would that be a great prize?
Coach Howard already did that.
Well, maybe that's in anticipation of your win already.
Oh.
It has to be virtual. I have a Venmo. Just saying.
Yeah. Oh, okay. Well, just saying I don't have Venmo, so sorry for you. And I didn't get my Trump dollars yet in my bank account, so
We haven't either. It's okay.
yeah. Well, somebody has to be last, right, Gracie? Somebody has to be first. Somebody has to be last. So I don't know. I'll come up with a good prize. We'll see.
How about a 4 on the what's it called?
A 4 on the exam?
Yeah, how about that?
Now I'm totally in charge of what grade you get on this. So yes, I have the power to
How
grant.
about 2 free phone calls during the exam?
Something tells me that phone calls to your stats teacher is something they've already thought about, and somehow they're going to be tracking that. I really don't know. I don't know what's to prevent students from calling me up and saying, "Hey Barry, here's the question. What do you think?" But I'm not going to answer. I'm not going to answer the phone during that time. Even if your computer crashes, even if you turn your coffee over on your keyboard and your computer don't call me. There's nothing I can do to help you. The College Board will give you instructions on what to do in that case, and they will, give you an opportunity to retake the test if they think you're being trustworthy and honest about what happened. Okay. So don't call me. I cannot help you. Don't call them. They won't have people answering the phone. You're going to submit your request for a retake electronically, and they're going to give you all the instructions about that, So I don't know. Let me think about what can I do. Maybe I could mail you some stats cookies in the mail. How's that sound?
I'm not giving you my address.
I already have your address. Your name is in Infinite Campus.
Dang it.
I can go into Infinite Campus and I can pull up your address on a map. I could drive to your house right now if I wanted to.
Please don't.
Trust me, I won't. Unless, I don't know. Yeah, maybe this. I'll make a box of stats cookies. And if you don't know what stats cookies are, then you'll find
I'm sure
out.
my dogs would love those.
I'll show you on Monday. You better not feed my stats cookies to your dog. I'll show you on Monday what stats cookies are. Okay. And so whoever guesses the true value gets a box of stats cookies mailed to your house. How's that? Does that sound good?
Deal.
Deal. Okay. So your assignments for today, for Monday, is just to go through the process of calculating, using your calculator, calculating the mean of 16 values from a normal distribution with a mystery M somewhere in the 200s probably, and populating that spreadsheet that I gave you the link for. And on Monday, I'll give you a dot plot, and we'll talk more about that on Monday. Okay. Now, if you do have questions about how to navigate the keystrokes on the calculator, you can always, I'll post this video and I'll post the link to it. You can always go back and watch, or you can just send me a message and I'll give you the keystrokes to get to something. Hey, how do I get to the mean? Whatever. I'll be happy to help you with that. Okay. Okie doke. Any questions? Now that we've satisfied Gracie's need to win a prize.
I need some encouragement to do the NTI.
You do. You need a tangible reward. I agree. So yeah, I think that's fair. That's fair. All right.
Can you explain how to do like the last part of the online AP classroom?
No.
The Gracie.
Can I explain? The question about the pH level? Huh? The type 1 error. I thought somebody might ask that question. So I printed out the questions. So you want to know about part C, right?
Yes.
Consider the situation in which the health inspector finds the sample mean of the 4 pools to be outside of safe pH levels. In other words, it's either he took 4 pool samples and the mean turned out to be below 7.2 or above 7.8, which is possible. But the true value, unknown to the inspector, of all the pools is actually 7.5. So if the population is really 7.5, the inspector will make an error. He will say, all the pools are unsafe based on my 4 samples. I conclude that all of the pools are unsafe, so they all have to be shut down and some magic potion has to be dumped in to adjust the mean. I don't have a pool, so I don't know what you dump in there, but you put in something to adjust the pH of all the pools.
Soda ash.
So find the probability that the inspector will make a type 1 error with the sample of 4 pools. Well, let me just sketch that for you. What's that going to look like? Well, we're already told that our distribution is normal, right? Yeah, it's normally distributed with a mean of 7.5. Normally distributed with a mean of 7.5. So our pool populations look like this. However, the population standard deviation is 0.2. But because we've taken 4 samples, we're not dealing with the population standard deviation now. We're dealing with our sampling distribution standard deviation. So that standard deviation now is sigma x bar is the population standard deviation sigma over the square root of n, right? So so that's the formula for the new distribution that we're talking about. And in this case, the population standard deviation is 0.2 divided by the square root of 4 because our sample size is 4. So 0.2 divided by 2. 0.2 divided by 2. Anybody going to tell me what that is really, really quick? My guess is that the new standard deviation is 0.1. You got a calculator there. You can verify that. But your new standard deviation is 0.1. So what's the probability that my 4 samples will lie outside the safe zone? Okay. So 7.2 and 7.8. Given that standard deviation, find the probability that the inspector will make a type 1 error. In other words, he will find a sample that is in one of these 2 areas and conclude that the population standard deviation is either here or here when it really isn't. Okay, that's what type 1 error is. And really the only reason I brought this up is because we'll be talking about type 1 and type 2 error, probably not next week, but the week after. And I just wanted to introduce the topic. But really all it means is what's the probability that he's going to calculate or he's going to find a value in this range or that range, given we have a population or sampling distribution with a mean of 7.5 and a standard deviation of 0.1. What's the probability of that? We've done that probability calculation many times before. You can use table A, or honestly, I'd use the calculator to do that calculation. But you can find the probability of these 2 tails. Now, one thing you can look at here is that this is symmetric, right? So the area in this tail is going to be the same as the area in this tail. And so if I were going to do this and use table A, I'd do the easy one. I'd do this one. Table A will give me this directly. And then just double it to get both of them because of symmetry. I know the area in this tail is the same as the area in that tail. Okay. So hopefully that gets you started. If that doesn't get you to where you want to be, just you can message me later, and I'll be glad to help you. I'll help you through it. Okay. Any other questions? All right, gang. We all have a great weekend. The weather's getting warmer now, which is good news. So go out and get some fresh air. Stay 6 feet away. Be safe. Don't do anything crazy yet. But I'm going to tell you here in a little bit, I'm going to go out and get some fresh air myself. Go mow the yard or something. So, all right, gang. I will see you on Monday. Y'all have a great weekend.
Bye.
See ya.